let me offer some insight over the most requested question from your homework number 4. That is the second problem of question number 2. Okay, when manager claims that the proportion is less than 10%, and do you have any way you can verify the claim? So for that, we need to rely on the hypothesis testing technique. So for the simplicity, let me just write down all the conditions. Okay, for null hypothesis, population proportion is less than 10%. Okay, alternatively, it is not 10%. You may have noticed that I'm using P0. This is hypothesized proportion. Okay, of course P is a true proportion and P bar is sample proportion. Okay, they all look the same, similar at least, but they're talking about things that are very different. P bar, you can obtain this, right? P, you can never obtain it. P0 is based on people's claim, okay? Because we are trying to test whether the claim is true or not. Therefore, we rely on the hypothesized proportion 10% here, okay? It basically means, yeah, I'd like to believe what you are saying is true, but let's see whether that's likely or not, okay? So that is the rationale behind why we are using P0 to construct a sampling distribution. So whenever we use the sample outcome to determine the true proportion, we are utilizing the sampling distribution of population proportion. So this sampling distribution has a property of average is equal to 10%. And standard error wise, we're going to have, you've done this, P0, 1 minus P0, okay? And then over N. So in our case, it was multiply 0.9 over 50 square root. This was 40424. Okay, this is a property of this distribution. It has hypothesized average of 10%. It has a standard error of 0.0424. Okay, so in this case, because we are testing whether P0 is less than 10% or not, it means we are only surprised when we have obtained a sample outcome that is too large. So we are testing the upper tail. Okay, what is the chance that a sample can occur in this particular region? Okay, so because our alpha is 0.05, so we need to find out this z value that gives us 0.05 of alpha. And it turns out that this is, let me do a calculation real quick. I think this is, yeah, it's 1.64. So 1.64. So what is this P? Okay, that sets apart this region and the other region. What is going to be the value of P bar? Okay, so here you are seeing two different regions. We're talking about the stories of two different regions. Okay, so assuming that the population proportion is 10%, okay, you may see the sample result can happen in all over the place. In all over the place, when the true sample result is 10%, but just not here in this area. Because if you're obtaining sample outcome that fell into this particular region, Okay, if you fail in this particular region, that probably means the true proportion is not 10%. So let's find out the value of p. So it's going to be p0 plus z multiply by the standard error. Okay, so p here is 10%, z is 1.64, standard error is 0424, and we do the calculation. Plus it's going to be 16,9,536. So this is the critical value of p that sets apart the acceptance region and rejection region. Nothing new, I'm just giving it a fancy name here, okay? Rejection region. Meaning whenever you have obtained a sample result that is greater than about 17%, you have a reason to believe that this is not true. Okay, this is not true. So because our sample size is 50, n is 50, let's see what is the count. Count corresponding uh, 16%, 16.95%. It's going to be 8.475. So anytime when you draw a sample, when you see red ball is greater than 9, okay, greater than 9, and then you have a reason to believe that this original claim of 10% is actually not true. Okay, if you obtain sample outcome that continuously give you 10 red bees, 11 red bees, 9 red bees, these are all falling into the rejection region. Okay, let's assume that one sample that gave you 12 red bees out of 50. Okay, what is the proportion? It's 24%. Okay, how likely 24% can happen in this particular distribution? Right, when average is 10, standard deviation is only 0.04. Okay, it's going to be miles away. It's going to be miles away from the center. Okay, there's going to be nearly 5-6 standard deviation in between these two guys. This p bar and average p0. It's going to be about 5-6 standard deviation in between these two. Therefore, this is highly unlikely. This is highly unlikely to happen when the population proportion is only 10%. Okay, so I hope this kind of helped you a little bit, and this will be the general step you need to take. I know this is kind of messy, but I have explained everything that is important in solving this question. Okay, most important of all, I encourage you to really try to understand the logic behind it. If you let go this time, next time when you encounter a similar problem that you need to solve based on the normal distribution, you will not be able to solve it again. Okay, I'm not saying in my class. Your class you'll be taking next semester, the semester after next, even in the graduate school. If you cannot solving this type of problem, I really feel bad for you. Okay, so grab opportunity. Opportunity here means when. Okay, I'm willing to help, If you have a further question, keep sending it to me. As long as you want to learn, and I can provide all means that I can help you with that. Okay? So don't give up and try to understand the logic. And this is it for this video. Okay? Thank you.